So when we have a large amount of information, just like it could be pages and pages of an answer or numbers or statistics, it's hard to process that. So our jobs as social scientists or regular scientists or people just trying to present good information is to find a way to present it in a way that makes sense and is accessible to the people that are going to be looking at it. So a big question in this is, what kind of chart or graph should I use? So let's take a look at the major types of charts. So these are pie charts. So pie charts are really helpful when there's a part of a whole. You have a whole amount of things and there's little sections of that. It doesn't always make sense to use a pie chart. It's often percentages. It doesn't have to be. It's just as long as there's a part of a whole. So take a look at these two charts. And which one do you think makes sense? Only one of them works as a pie chart. The other one does not make sense. So this first one, where does our water go? This shows us a certain amount of percentage in our house of where water would end up when we end up with using water in the house. You can see toilet 26%, clothes washer 21%, shower 16.8. So those are percentages. That's a part of a whole. This graph makes sense. So this graph over here, what we ate yesterday, does not make sense. Here's why. Percentage of people who surveyed who ate meat. So maybe 43% of people ate meat, but some of those same people could have eaten bread, and some of those same people could have eaten vegetables. And so this graph by itself does not make sense because these are not mutually exclusive things. And so it's not a part out of a whole. So this graph doesn't work for this question. Here we go. This is a bar graph type thing. Bar graphs are really, really good when there are categories, and they can go up and down, or they can go sideways. And the categories with amounts. So here we go. You can see like this graph is the median annual earnings by education, age 25 and older. So you can see, generally speaking, as people get more education, that they have a higher income. There is a difference in this graph between men and women. The coloring of those bars is really helpful to be able to see the difference. And it generally kind of goes up with education, and that makes sense. And generally speaking, women make less money than men. I will say this is from 2010, and I think the situation has gotten, actually, I know the situation has gotten better since then, just so you know. But this has categories and amounts. That's when we use bar graphs. Pictographs can be really powerful when the picture helps make sense of the data, showing amounts. So this is just like a visual, powerful view of bullying, and this shows the actual amount of sugar that you find in each of these drinks. By the way, don't ever drink soda, it's bad for you. That can be useful in pictographs or physical representation. And line graphs. Here's the thing about line graphs. You need two numbers. You need numbers on the x-axis and numbers on the y-axis to be able to create a line graph. Otherwise, it doesn't even work. So both the independent and dependent variables are numerical, are numbers or amounts. And it also works with line graphs when there's only one y value per x value. This has two different statistics happening on it. And so, but for the orange line, there's only one y value for every x value, and same thing for the blue. So, and there's usually a trend when you use a line graph. If there wasn't a trend, then the line would go all over the place and it wouldn't really make sense. Scatter plots, also you need two numbers. You need a number on the x and number on the y. So this is like a height and weight comparison. But you can use this when there's a lot of data, and the independent and dependent variables, again, have to be numerical, but it could be all over the place. And this shows a trend line. This shows that, and it makes sense, right? As height increases, weight increases. So this scatter plot has a lot of data points all together. That is when you use scatter plots. So next we're going to look at how we process data. How do we get to these amounts?